Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science from 2025 Physics Paper 1 Higher Tier. Question number 3 is on the topic of electricity. A student investigated the resistance of a resistor. The student used the resistor, a cell, a switch, an ammeter, and a voltmeter. Draw a circuit diagram for a circuit the student could use to measure the resistance of the resistor. Now, if you need to measure the resistance, you need the current and the voltage, which is going to be given from the ammeter and the voltmeter. So let's start by drawing the cell. To the cell, we are going to draw the ammeter first in series. And then the fixed resistor. To the fixed resistor, we are going to draw the voltmeter, which is going to be connected parallelly. Now you need to make sure that all the lines are connected and there's no gaps in the lines in the circuit. So we have the cell, ammeter, you don't have to label it, resistor, and the voltmeter. The student added a variable resistor to the circuit. Use the variable resistor to change the readings on the ammeter and the voltmeter. Recorded several different pairs of readings from the ammeter and the voltmeter. When the reading on the ammeter was 450 milliamps, the reading on the ammeter was 450 milliamps, the reading on the voltmeter was 2.7 volts. Calculate the resistance of the resistor. So resistance is capital R. The voltmeter reading, that's V, and that's I. So we are going to use the equation V equals IR. Now before we do that, let's convert 450 milliamps to amps. You would divide that by 1000, so you would get 0.45 amps, which usually carries 1 mark here. So using V equals IR, voltage is 2.7 equals 0.45 multiplied by the resistance. Rearranging the equation, R equals 2.7 divided by 0.45 should give you 6 ohms. So the answer is 6. The student plotted a graph of current against potential difference for the fixed resistor. Complete figure 2 to show a sketch graph for a fixed resistor at a constant temperature. That would be a straight line going through 0. So just make sure it goes through the center point. Remember, you have to remember 3 different graphs. This one is for a fixed resistor. For a filament lamp, it would be an S-shaped graph. And this is for a filament lamp. For a diode, oops, let me redraw that. Like that. That's for a diode. Figure 3 shows 5 resistors with the same resistance but different power ratings. Now this is the first time I've actually seen in an exam question where they are giving you resistors with these color bands. Now we don't have to panic because they're not asking anything about the color bands itself, but this is what actually resistors look like in circuits. The power rating of a resistor is the maximum energy the resistor can transfer each second without overheating. Each resistor has a resistance of 2.2 kilo ohms. Determine which resistors in figure 3 are suitable to be used in a circuit that has a maximum current of 0.012 amps. So that's the current. This is the resistance. So let's convert 2.2 kilo ohms to ohms. That is to basically, you need to multiply it by 1,000. That would give you 2,200 ohms. That gives you a mark there. Using the equation, so what are we trying to do? We are trying to work out the power rating so that we can compare it with the power ratings above. So the equation that we are going to use is P equals I squared R. So let me just double check something. Yeah. So 0.12 squared multiplied by 2,200 would give you a power of 0.3168 watts. So this should give you 2 marks for the equation, substitution, and the answer. So which resistor could be used? So as long as the resistor has a power rating of above 0.3, it should be okay. So which means you cannot use D or E. So you could use A, B, or C. So suitable resistors are A, B, and C. It's not just one answer because the question is asking determine which resistors. So it has to be more than one resistor. That's the end of the question. Thanks for watching, and I will see you in the next question.